action. Okay, so in this part 2 of trig, we are going to be looking at non-permissibles. We're going right to the next page. Now, non-permissibles happen in trig just like they happen in anything else that has fractions. Now, here's two scenarios. Well, it's going to happen in tangent, cotangent, secant, and cosecant functions, okay? Now, if you look at tan x, when can you not do tan x? Well, tan x equals sine over cos x, right? So it would be really bad if cos x equals 0. Now, cos x does equal 0 sometimes. When does cos x equal 0? Okay, there and, right, so pi over 2 and 3 pi over 2. See, at those points, tan doesn't exist, aka undefined. So undefineds are not good. And what makes them undefined is non-permissible values. Okay? So what else? Well, if you have cotan, well, cotan is cos over sine, or cosecant is 1 over sine. So there's a place where sine can non-permissible when sine equals 0. Now, when does sine equal 0? When does sine equal 0, you guys? Anyone know? 0, pi, and 2 pi, right? So 0, pi, and 2 pi. Now, I guess I should go back, and more generally, this would be pi over 2 plus n pi, right? Like that's the way we just say it quicker. And then this one would be just n pi. And of course, n is in the integers. So today we're just going to be scouting them out and finding non-permissible values. Okay, so let's, just for sake of time, let's just do example 2. Now it says prove that sine x cos squared x plus sine cubed x equals 1 over cosecant x. Okay, now that looks like a nightmare, but let's see how it goes. Now the first thing, I'm going to write them down, right? I got sine x cos squared x plus sine cubed x, and then equals 1 over cosecant x. Now, right away you could say, why don't you just make that, like 1 over cosecant x, why don't you just make that sine x? If you do that next step, that's fine. But do you remember how when we were doing non-permissibles, if it was ever bad, it's always bad? Do you see how 1 over cosecant x is not the same thing as sine x when it comes to non-permissibles? Because is this one going to have a non-permissible? Yeah. Does sine x have a non-permissible all by itself? No. So, right? Don't just right here go, oh, I'm going to put sine x, because it actually changes your question. Now, let's see what we can do on the left side. On the left side, I can make that, I can take out a sine x, right? Leaving me with cos squared x plus sine squared x. Now this is almost an insult to your intelligence, because what does that equal? 1. So this all equals sine x here. See how brutal it looked? Do a little math. You're out of the woods. Now, you're going, but that doesn't look like the other side. Well, the other side is the same thing as 1 over sine x, which equals sine x. Now, right now you're going, I thought you keep one thing still. Sometimes I'll move the other one when I totally know it's good, because then, or I could just take sine x and make it 1 over cosecant x, but then I'll be making a non-permissible. That's okay too. You could have done that. Okay? You could have taken this and made it 1 over cosecant x, and then just dealt with the non-permissible. We got to deal with it anyway. Now, this one is an extremely, what I would say, uh, high-level question, because do you see that cosecant x, it cannot be two things. What can cosecant x not be equal to? Well, what's one thing for sure this can't equal? 0. What's another thing that it can't equal? What if this equaled undefined? Can you take 1 divided by undefined? So we know that cosecant cannot equal 0, right? Okay, so, and we know that cosecant cannot be undefined. See, do you see, if you made this into a 0, it's 1 divided by 0, correct? And then it would be 1 to... Now, could I make cosecant equal 0 in this case? No. But I wanted you to see that, because sometimes you can do some, like, you know what, cotan. If this would have been cotan, which is a way better question, you can make cotan equal, can cotan ever equal 0? Yeah, because cotan is cos over sine, right? So if cos equals 0, then it all equals 0. So I wish this one actually said cotan, okay? But then it doesn't. So we'll say doesn't happen in this case. But I wanted you to be aware that sometimes you got to make sure that it doesn't equal 0 and it doesn't equal undefined, because 1 divided by undefined is bad. Now, when does undefined happen? It does happen when sine x equals 0, right? So when does sine x equal 0? Happens at, so n pi, right? Where n is in the integers. So x cannot equal okay. Let's keep on going. Okay. So the next one's a lot of fun because there's a lot of bad stuff in that one. This cannot equal 0, correct? This cannot equal undefined. What about cos A? Can equal -1, right? What about tan A? Now you're saying, but tan's on the top. But tan is sine over cos, right? So cos can't equal 0. You getting all this stuff that's kind of like weird that you got to be thinking about now? Okay, so let's prove the identity. This one's pretty ugly. Okay, so let's work with the left side. Now, so I'm just going to work with this. I'm going to try to make it look like 1 over cotan A. I'm just wondering if... Okay, yeah, let's do it. Okay, so Sine A. Now, so I would do this first. Sine A plus sine over cos, or sine A over cos A, all over 1 plus cos A. This is a pretty high level one. Okay. Now, remember, I'd like to get these two together. So the best thing I can do is multiply this by cos over cos, right? So these two can add. So then I would have cos, actually, I need the room here, so I'm going to go close. Cos sine A, cos A sine A, plus sine A, all over cos A. That's all over 1 plus cos A. Okay, so hopefully these are getting a bit more familiar now. So now do you see here, I can take out a sine A, right? So this would be sine A. That's going to leave me with cos A plus 1 all over cos A over 1 plus cos A. Okay, now what's sine A over cos A? So this is the same thing as tan A times cos A plus 1 all over 1 plus cos A. Now, do you see that cos A plus 1 and 1 plus cos A are the same thing? Just be careful. Is cos A minus 1 the same thing as 1 minus cos A? No. So it works for addition. Okay. And what is tan A? That is. So I'd just be left with tan A, which is the same thing as 1 over cotan A. Now you're looking at it going, oh, I would have thought of that. Right? Okay, what are the non-permissible values? Okay, let's go through all of them. So the first one I'm going to talk about is that tan A at the top. So tan A equals sine A over cos A. Therefore, cos A cannot equal 0. Now again, where does cos A cannot equal 0? Here and here. So I would say A cannot equal pi over 2 plus n pi. N is in the integers. Okay, so I got tan A covered. Now if you want, go and check them off. Okay, tan A is done. Let's talk about cotan A. Cotan A equals cos A over sine A. Okay, so therefore sine A cannot equal 0, right? Because it's on the bottom. So that happens here and here. So that is A cannot equal n pi. N is in the integers. Okay, now cotan A can also, what would be bad is if cos A equaled 0 too, wouldn't it? Because then that'd be 1 divided by 0. But guess what? I already covered that one. Does everybody get why cos A cannot equal 0? Because 0 divided by sine, whatever it is, would be 0. So cotan A would be 0. Therefore, 1 divided by 0 is undefined. So cotan A cannot equal 0. But I already covered that. Okay? Is there a question? No? Okay. So also I could say cos A cannot equal 0, but already done. Okay, now we also said, for number 3, cos cannot or equal -1, right? Because if you go up here, 1 plus -1 is 0, and you can't divide by 0. So when does cos equal -1? Where does it equal -1? Just at pi. So this would be pi. So I would say a, oh, I forgot to put a non-equal sign up there. A not equal pi plus n pi. Or no, I guess I'd have to say plus 2 pi. N is an integer. That's true. Yes. So then I would say, just like you said, but already stated. So that would be redundant, right? But it's okay as long as I looked at it and believe. Right here, right? It's not allowed to ever be here. So it's already stated up here. Tricky stuff. Okay, do I have all of them, you think? Yeah, I think we're pretty good. Okay, now let's just do, we can prove it out, or you could do, if you do these on the calculator, sometimes it doesn't leave a little space in there. So, okay. Let's just do a proof here. Now this one didn't even ask for non-permissibles, but you've got just a little practice. We got secant squared over secant squared minus 1. How does this equal cosecant squared? Well, right away, does anyone know what this equals? Can't hear you. Tan squared. So this would be the same thing as secant squared x over tan squared x. Okay, so I'm just going to work with the right side. So cosecant squared x, go hug a tree, I'll come find you. Okay, now, so this is the same thing as 1 over cosecant squared x, and this is sine squared x over cos squared x. And always make this line like long, so you're not getting all screwed up which is which. Okay, that's the big division sign. And then I find that students do see how to do these much easier if you multiply by the reciprocal over sine squared x. So 1 over cos squared x times cos squared x over sine squared x. And now the beauty appears. Cross that out. We have 1 over sine squared x, which equals cosecant squared x. Okay, so we're doing questions 1 to 4, A, C, E, and then 5 to 7. Okay, I'm just scrolling through the homework quick before we go to the next lesson, so if anybody's sick today, they can have the homework at home. 1 to 4, ACE, and 5 to 7. Okay. Okay. Now we are working on sum and difference identities. Now, the great thing about the unit circle is there's lots of stuff on the unit circle. The bad thing about the unit circle is it's missing lots of stuff. If I asked you what's sine of 15 degrees, I don't want exact, okay? Not decimals. You guys couldn't do that. Or sine of 50, okay? But after today, that won't be the case. We're going to learn how to use all of these. So, do you have to memorize them? Absolutely not. Do you need to know them? Absolutely. So, the point that I'm trying to make is if you know they're there, you're going to know how to use them, and you're going to be able to do weird angles like 15 degrees. Okay, also there is tan A plus B equals sine A plus B over cos A plus B, which is this all over this. Okay, which comes all the way down to these. Okay, so we're not going to go through the algebra how to solve them. They're on your formula sheet. So you see we're going down it pretty quick now. You see we're all the sine A, cos A, so we're just down to here now. We got here to here in like 2 days. Okay, and then your tan A minus B. Now, let's do a couple questions so you can see how this works. Express 15 degrees as a difference of two special angles and hence determine the exact value. Okay? Now how are you supposed to pull off the exact value? Well, do what you know. Now you don't know how to find 15 degrees. But you get out your unit circle, and is there two things you can add together or subtract that will give you the answer 15? What are they? Okay, so you can do 45 degrees minus 30 degrees. And I'm supposed to find the sine. So I want to find sine 45 minus 30. Now if you go to your fancy formula sheet, you can see that sine A minus B is sine A cos B minus sine A cos B. So I highly recommend doing this. Label them A and B so when you're going through you're not mixing them up. Okay? So it is sine A, so sine 45 degrees, cos B 30 degrees, minus cos A, which is cos 45 degrees, sine B, sine 30 degrees. So if you suck at your unit circle, these aren't going to go well. Okay? Yeah, and yes, we have time. Even though I'm sick, we will play the game. Okay, let's do this. Sine 45. Come on, what is it? 2 over 2. Cos 30. Root 3 over 2. Minus cos 45. Root 2 over 2. Sine 30. 1/2. Okay? So when you know your unit circle, these are easy. If you don't know your unit circle, you are in for some fun. This is a 5-minute question if you don't know your unit circle. A 2-minute question if you do. So I'm going to do some math. Root 2 times root 3 is root 6 over 4. Minus root 2 times root is root 2 over 4. Now you cannot subtract root 6 minus root 4. So the best you will get is root 6 minus root 2 all over 4. I just put it all over one common denominator. Pretty cool, eh? Now, I don't know how you're getting this one if you didn't show up for class. You do have the advantage of putting both into your calculator till you get the right answer. Same decimal. Now, I told you that doing radians is easier than doing degrees, but this sometimes becomes a challenge. But I taught you how to build your unit circle by putting all the 30 degrees, or all the pi over 6s over what? Over what number to count them? Okay, over 6, and all your 45s over 4. What you really want to do now, since 4s and 6s can now be intertwined, what should be a good way to convert everything to? Over 12s. So when it says get the answer 2/3 or something, and you're like, what? Well, I know that one already, but what about 5 pi over 12? Well, right away they're baiting you with that one. Get it over 12. Okay? Now, how do we do this one? Okay. What are two numbers that will give you the answer 5 pi over 12? Okay. Any over 12s, what are good ones? Is 2 over 12 a good one? Because what if we went 2 over 12 plus 3 pi over 12? Does that make 5 pi over 12? Okay, good. Now see if they're on your unit circle. Pi over 6 and pi over 4. So we're going to go 10. Yeah, okay. Here's the other kicker. Instead of going cotan 5 pi over 12, hold on, I'll just pause recording. Okay, so if I got pi over 6, so I'm cotan 5 pi over 12 is not good for me right now. So I'll do tan, and then my final answer, I'll flip. Does that make sense? Okay, do what you know. So let's do tan. We'll do tan pi over 6. Now, if you go to tan, it's kind of ugly, right? We're doing a plus b, so it's tan a plus tan b. So I'm going to put a and b here. It helps me a lot. So if you're on your formula sheet, it is tan a is pi over 4. Oh, crap. Okay. I'm going to be totally opposite my notes here. Yep. Because cotan, it wants us to find cotan of it. So tan's easier because I know it on my unit circle. And I can flip my answer at the end. Yeah. Okay. So now I've done this 100% backwards, so it's good for me too. So this is tan pi over 6 plus tan pi over 4. You can see how it's not going to make a difference there if you mess up a and b. And that's over 1 minus tan pi over 6 minus pi tan, times, tan pi over 4. Okay, let's get some numbers out. So what's tan pi over 6? What is it, guys? Come on. Everyone should be yelling these out. What is tan pi over 4? Plus 1. What is 1 minus? What's tan pi over 6? Okay. And tan pi over 4 is 1. Okay, so this is root 3 over 3 plus 1 over 1 minus root 3 over 3. Okay, now what we want to do, since it's cotan, I'm going to flip these around. So cotan would equal 1 minus root 3 over 3, and I'm going to change this to 1 plus root 3 over 3, just because I can, right? Still not looking like the top, though. Okay, so then there's a trick to this one. Take this entire top and multiply by root 3. And the entire bottom and multiply by root 3. Again, you're going, I would have never thought of this. I'm showing you, so now you ever come into this kind of situation, you're going to do it. Okay, so root 3 gets multiplied to both of those. Now, 1 times root 3 equals root 3. Now, what happens when this root 3 gets multiplied to this root 3? Turns into 3. What's 3 divided by 3? Look at that. So, again, root 3 times root 3 is not 9, it'd be root 9, which is 3, and then you take your 3 divided by 3 and you get 1. Okay, and same scenario on the bottom. Take your root 3, multiply, you got to distribute, right? So that'd be root 3 plus root 3 times root 3 is 3, 3 divided by 3 is 1. Okay, done. Okay, now, what's the answer to this? Now, you're probably saying, I would just put that in my calculator. And maybe that's not a bad idea. But what if I had to find this algebraically? Now, you don't know sine 100. You don't know cos 10. You don't know the exact answers. So, this is what you can do. Now, this is so you know sine A cos B minus cos B cos A sine B. If you look on your formula sheet, that is the same thing as sine A minus B. Which would equal sine 100 degrees minus 10 degrees, which equals sine 90 degrees, which equals 1. Okay, how about the next one? This one looks like, now this one's kind of tricky, because this entire thing would be A. This entire thing is B. So this would be A, and this would be B again. So that would be, which one? What goes cos A, cos B minus sine A, sine B? Cos A plus B. So this would be the same thing as cos A plus B. You're looking on your formula sheet, right? So you're just matching. And that would be cos 1/4 pi minus theta plus 1/4 pi plus theta. Now, do you see how you have a negative theta? Oops, this looks like a 0, sorry. And a positive theta? They would cancel. And what's a 1/4 pi plus a 1/4 pi? 2/4 pi? Or a half, yeah. So equals cos 1/2 pi, or pi over 2. What's cos pi over 2? 0. Oh, we're going to have lots of time to play the game. Okay. Now, this one here takes it to a whole other level. I will definitely put one of these on my test. This is a great written response question. Um, I'm planning on it being on the diploma, or I wouldn't waste time with it. Okay, we have cos A equals 3/5, cos B equals 5/13, where A is between 0 and pi over 2, and B is between 3 pi over 2 and 2 pi. Find the exact value of cos A plus cos B. Now, the formula for cos A plus B, if you look on your formula sheet, is cos A cos B minus sine A sine B. So, what is missing here? I can't find cos A plus B because I do not know what sine A equals or what sine B equals. Because I don't know what A or B is. But we're going to do some thinking. Let's talk about this one first. Okay. So I've got to be in first quadrant, right? It says it's between 0 and 2 and pi over 2. And it's when cos A equals 3/5. Like, huh? What are we talking about? Well, this equals adjacent over hypotenuse, right? So you draw a triangle there. Again, you may be going, I never would have thought of this in a million years. Well, that's why we do these notes, okay? Now, that means this is 3 and this is 5. So I've got a friend. He's not really my friend. I've never met him. He's called Pythagoras, and he will help me find that other side. Why do I need it? Because sine equals opposite over hypotenuse, right? Therefore, I will have what sine A equals. Okay? So this would be y, right? So let's solve. So we would have 3 squared plus y squared equals 5 squared. Now, you will get good at this, but you will know right away that y equals the square root plus or minus. Remember, figure out what quadrant you're in after. That would be 5 squared minus 3 squared. It'll always be the hypotenuse minus x or hypotenuse minus y. If you ever screw that up and you put y minus the hypotenuse, you'll always get error because the hypotenuse is the biggest side. So I'll give you a negative under your... Okay, so y equals plus or minus 5 squared is 25. 25 minus 9 is 16. So y will equal plus or minus 4. I'm going to conclude that it is plus 4 because of the quadrant it is in. So now, guys, I know that sine A equals 4 over 5. Now, do you see why this is such a great written response question? I see a picture, you picked the right quadrant, you did Pythagoras, you found sine, then you had to do number 2, where B is between 3 pi over 2 and 2 pi, so I am there. Okay, again, draw your triangle always to the x-axis. Now cos again is adjacent over hypotenuse, so adjacent is 5, hypotenuse is 13. So again, I'm looking for y. So y equals square root of 13 squared minus 5 squared. Okay, so we're going to get y, oh, forgot my plus or minus, y equals plus or minus square root 144, y equals plus or minus 12. Which one am I picking? Minus 12. So I'm going to go with the minus 12 because of the quadrants it's in. So pictures are so valuable here. No one right now is questioning why it's negative 12 because they're looking up here at a picture I drew and so yeah, why is there negative here? Okay? Don't draw this picture and it doesn't make sense. Okay? So do yourself the favor. So then this one, sine b equals negative 12 over 13. So I got it all now. So I'm going to find cos A plus B. What's cos A? It says it's 3/5. What's cos B? It says right up there it's 5/13. This is where I need to do all the work though. Where's sine A? Oh, it's 4/5. What is sine B? I'm going to put it in brackets because it's negative 12/13. And remember, those two are timesing by. If I left the brackets out, it would look like they're subtracting, and I don't want that. Okay, so then I've got 3 times 5 is 15 over 65. And that's going to be a minus. I can just do this. Minus, it's 4 times negative 12. Negative 48 over 65. So that's 15 minus negative. So that's 15 plus. So that equals 63 over 65. Now be honest. If you were making a math test, you'd want to know if you guys know how to do this. Right? So again, test wiseness is also knowing what to study. But I'm not going to lie to you. Because do I want you to know how to do these? Yeah. So I'm going to tell you there's going to be one on the test. Because I get my goal, which is everybody comes prepared to know it. You get your goal, get it right, and get a better mark on your test. So we're all happy, right? Okay, so 1 to 3, A, C, E, ... and 4 to 11.